All right, again, good evening, everyone. And thank you, Henry, for joining us and everyone, the Alexandria Library's talk tonight with Henry G. This discussion is being recorded and eventually will be available through the Alexandria Library's YouTube page. My name is Megan Zimmerman, and joining me is my colleague, Bianca Brown. We're fortunate to have Bianca here with us to help with technical difficulties and answer questions you might have during the talk. If you do have questions for Bianca, please use the chat feature. If you have questions for our author, I ask that you use the Q&A feature. Both of these can be found by clicking on the icons in the middle bottom of your screen. And I want to thank Maria Mann, Senior Publicist at Fortier Public Relations, for helping to coordinate tonight's discussion. Our author is Henry G. He is a paleontologist, evolutionary biologist, and an editor at Nature, the leading international weekly journal of science. Over his long-standing career with Nature, Henry has brought to the world the biggest discoveries from our scientific and natural world, including the first feathered dinosaurs and Ardipithecus ramidus, Lucy's hominid predecessor. I see some are having difficulty hearing me. Can you hear me now? Great, okay, I'll try and talk a little bit louder, thank you. Henry is the author of several books, including Jacob's Ladder, In Search of Deep Time, The Science of Middle Earth, A Field Guide to Dinosaurs, and the Accidental Species. He's appeared on BBC television and radio, NPR's All Things Considered, and has written for The Guardian, The Times, and BBC Focus. He lives in Cromer, Norfolk, England, with his family and pets. Henry's brand new book, released on November 9th of this year, so less than a month ago, is a very short history of life on Earth, 4.6 billion years in 12 pithy chapters. Over the course of those 12 chapters, Henry takes readers from the very formation of the planet, the beginning sloshes of life through the many starts and stops of past ages, all the while sharing the remarkable evolutionary advantages that enabled surviving beings to adapt and thrive in the changed world. Henry, thank you so much for staying awake to talk with us about your fun and fascinating book. If you have questions for our author, feel free to use the Q&A. And while people are getting those into the questions in, I wanted to start with a question. What prompted you to write a book that spans the history of life on Earth? Did you always plan to keep it so brief?
I'd had a thought for quite a while in the back of my mind. You know, it's like the back of your shed where you keep the barbecue and the bicycle you don't use anymore, and other garden tools, that I might write something on the history of life. I call it Henry's History of Life or something like that. But it didn't get any further than a little idea until I'd just written a book. It was a rather technical book for students about the origin of vertebrates. When I interrupted my colleague David Adam at Nature. He's not at Nature anymore. He used to be one of our news writers, and he's written a couple of good books about psychology. One's called The Man Who Couldn't Stop, about his own struggles with obsessive compulsive disorder, and he wrote another one called The Genius Within, which is all about mind hacks to help you pass exams and that. So we'd get together and talk about our works in progress, and I'd just written this book, so he asked what I was going to write, and I said, I'm not going to write another expletive book, which is what I always say when I've just finished a book. But he ignored me and said, why don't you write a book about all these wonderful fossils, the papers concerning which have passed across your desk over the 30-something years you've been at Nature, Henry, he said. So I thought that was actually quite a good idea. So I went and wrote the book. It wasn't quite the book that you see now. It was actually longer and more rambling and had more anecdotes, and it was about the people who discovered the fossils and some stories and anecdotes. My agent was very interested in this, And she said, well, send it over. And I said, well, no, I want to finish it first because I want to clear it with all the people I mentioned in the book. So I did. It was called Let's Talk About Rex, A Personal History of Life on Earth. But then I sent it to my parents, who are my sternest critics, and they said, well, it's all very nice, dear, but who, apart from the people in it, are going to be very interested? And I said, And Jill, my agent, was more tactful, and we basically condensed and thought and rethought, and it became the book that I'd always intended to write from the beginning. So it's like many things, you start with a simple idea and it has to get awfully complicated before it gets simple again. And so I had this idea to write a very short book with the whole of the history of life in it, but to be read as a story. I wanted to do it as a story. I wanted to keep it away from being very didactic in the traditional popular science way. It's impossible to avoid. But I put all that stuff in the notes. I would have loved it to have been a bit like the Talmud, with a bit in the middle with all the commentary around the edges, but they don't like doing that these days in publication. It's too expensive. So there's a lot of notes at the back. So it's very simple. It even starts once upon a time. And I thought, the history of life is a great story. It's got amazing vistas and incredible events and heroes and villains and cliffhangers. And why can't you just tell it as a story? So that is what I did. And I can't believe it's actually turned out so small. You can hold it in the palm of your hands. This is the US version that you'll see. The UK version is much bigger. I don't know why they have the same things in it, but it's actually quite small, and quite a lot of it is the notes. So you could actually put it in an inside pocket. And although the subheading is 4.6 billion years, I do give an extra billion years for free near the end. You don't pay for that billion. You only pay for so there's a free billion at the end, which is talking about the future of life on Earth, because I wanted to do all of life from its beginning until its end. Also, Megan or anyone, please feel free to interrupt me by posting a question or just pinging Megan or Bianca, and because I will just keep talking until I'm begged to stop.
No, that was great. Yeah, I will just echo that. Feel free. We will. Henry is thrilled to answer your questions if you have any. I will ask you. I have to say I'm not a don't have any science background, so reading this was very informative for me. And I was thinking, most of us have sort of this vague idea of, the asteroid that came and contributed to the end of the dinosaurs. But reading your book, I discovered that there are many instances where life was on the brink of extinction. But as you write, life has a tendency to rise to challenges. Could you talk a little bit of how life kept popping back up from these brinks of disaster?
Yes, I think if life had a motto, it would be whatever doesn't kill you makes you stronger. Life began very quickly after the Earth was formed. I mean, almost indecently quickly, while the Earth was in quite a state of ferment and general brouhaha. And so life is used to challenge. But what life tends to do as a whole is respond to massive glaciations or asteroid strikes by ramping up complexity, and by doing that becomes more economic to run. So one of the first big challenges to life was about 2.5 billion years ago, in an event called the Great Oxidation Event, which included an ice age that lasted 300 million years, in which the whole of the Earth was covered in ice. And at the time, the only living things were bacteria, which are very small, but bacteria tend to live in groups and of different species living together. So what the bacteria did was find a way of living together more closely and evolving very interconnected colonies, which became cells, the cells that we're made of. And these can go further with less and acquire more resources. Now, I do have, Chris Rosenthal has asked, what is my favorite era or chapter? So can I go ahead, Megan, and just freewheel and answer? That's great.
Absolutely, yes.
Well, I'm going to bang a drum for the Triassic period, which is before the Jurassic period. Now, the dinosaurs originated in the Triassic period, which was from about 250 to 200 million years ago. And because the dinosaurs originated in the Triassic, they tend to get all the headlines. But the Triassic was a fantastic period. It was the period immediately after the greatest environmental catastrophe in the last 500 million years, which is the end Permian mass extinction, where almost all life died out as a kind of perfect storm of volcanic eruptions and continental drift. After the Permian, the world took about 10 million years to recover, but when it did, oh boy, it was a golden age for reptiles of all kinds, and some of them were really, really strange. Flying reptiles began in the Triassic, and we tend to think of flying things using their front legs as wings, but there were some that just used their back legs as wings. Turtles began in the Triassic. There were turtles with shells on their tops and shells underneath, and shells partly underneath and partly on top. So the world was full of turtles, mock turtles, and teenage mutant ninja turtles, and all kinds of turtles. There were a lot of other things. Mammals originated in the Triassic. Yes, the dinosaurs originated in the Triassic and became successful largely as a matter of luck. And if you read my friend Steve Broussat's book, The Rise and Fall of the Dinosaurs, that explains it. So the Triassic is mine. I've got another one from Steve Young. Do I think that key components of life arrived here on Earth from elsewhere in space? They could have done, but it's very difficult to say. The oceans formed on the Earth. The oceans formed on the Earth largely when the Earth was cool enough for all the water vapor to condense and fall as rain, and it rained for millions of years, millions and millions of years, that would have made Seattle look quite sunny. But there were comets that and asteroids that hit the Earth, and a lot of these comets contain ice and some organic molecules. So I have to say, Steve, I don't know. I don't think it's really necessary. My feeling is that molecules such as RNA were quite late in the origin of life. I think what you need to start with life is have some way of separating the inside from the outside. And the cell membrane, I think, was the first thing to happen. I'm getting lots more here. Greg Bozonsky says, what was the status of the humans in my favorite Triassic period? The humans weren't there. They came along a lot later. And although I do talk about humans in my book, humans are quite a fleeting thing. Modern humans originated about 300,000 years ago in Africa, and were a pretty raw ingredient, and had to be winnowed by a lot of tragic experience, by nearly dying out at least once, and interbreeding with other more refined humans like Neanderthals to become more successful. Right, yes, I can answer that one. So that's that one. So to return to Will Rivers, could I pick a few? Will Rivers asks, could you pick a few particular fossils as being the most important ones for their impact on shaping the science of paleontology, i.e. those discoveries that really changed our understanding of the history of life on Earth? Well, gosh, there's so many one could choose from. So I hope you won't mind if I pick my favourite one, which came across my desk in March 2003, I think, which was the little hobbit creature from the island of Flores in Indonesia. Now, Flores is one of those islands that form a little chain. If you go to Java and you look eastwards, you get to Lombok and Bali, and then Flores and Timor, and then you get to Australia. So this chain of islands was very, very interesting to archaeologists who were trying to answer a pressing question, which is when it was that human beings first made landfall in that magic land now associated with Waltzing Matilda, Cold Lager, and the adventures of Priscilla, Queen of the Desert. And there have been a lot of answers. Was it 60,000? Was it 40,000? People don't know. So in a cave in Flores that has been quite well excavated for some time, people were looking for remains of modern humans, but that is not what they found. They found the remains of a very, very strange creature, only about 3 feet tall, but with huge feet, 6-9 inches long, which was called the Hobbit, Homo floresiensis, which was the remnant of an early human population that got marooned on Flores and evolved to become very small. Now, animals on islands do strange things. The big ones tend to become very small, and the small ones tend to be very big. So on Flores, there were Komodo dragons, but 3 times the size of the modern ones. And also tiny elephants the size of little ponies. Also giant rats the size of terriers. Now, the rats are still around. Flores has 3 types of rats. It has big rats, middle-sized rats, and small rats. I know this because I was there and I helped look at the bones of them. But that was completely unexpected. Also, it existed until comparatively recently. Originally, it was thought to have lived until 18,000 years ago, which is no time at all. But some revision puts it back at 50,000. But as science has accumulated, one finds that about 50,000 years ago, there were at least 5 different kinds of human on the planet. And we are the only ones left. Soon after 50,000, they all died out. So that is probably my favorite because it changed our entire view of human evolution at a stroke. So that one is the most important one as far as I was concerned. So thank you, Will, for that question. I mean, there were loads and loads of other fantastic ones, and I mentioned a few in the book. Now, David Rousman asks, can I say a word about the role that appetite played in the evolution of vertebrates? As I understand it, it was phosphate rather than calcium that allowed our bones to withstand acid. Now, this is not appetite like this. Excuse me, it's midnight where I am, and I've got the midnight munchies. It's appetite, A-P-A-T-I-T-E. Now, in the Cambrian period, about 540 million years ago, there was an immense period of weathering in which more or less the whole of the soil and rock on the Earth's surface was washed into the sea. This was important to all the creatures lived in the sea because it infused the sea with minerals based on calcium carbonate, which forms shells of most things, clams, crustaceans, but also calcium phosphate, which is the appetite you mean. And calcium phosphate became the mineral fraction of bone, which is a tissue unique to vertebrates, that's backbone animals, including ourselves. The first vertebrates were entirely soft-bodied. They didn't have any hard tissues, but they soon acquired bony armor on their outside. They became quite heavily armored. They had helmeted heads and fins covered in bony scales, probably as an evolutionary response to withstand being attacked by monstrous sea scorpions called eurypterids, which could be 2-3 meters long with great big goggly eyes and like to eat fish. But there is another reason why vertebrates used calcium phosphate rather than calcium carbonate, and that is phosphorus is a limiting material in the sea, and phosphorus is also an essential component of DNA. Vertebrates have genomes, in other words, genes made of DNA, twice as big as other animals. So having a little store of minerals on board would have been a good way of harboring a scarce resource in the sea at that time. Thank you, David. Thank you, Bianca. Susan Dexter said, why do humans have such similar DNA to mice? Well, we have similar DNA to lots of things. In fact, the similarity of the DNA of all creatures to each other is a good argument for the common ancestry of most organisms on the planet. Now, humans and mice have very similar DNA because humans and mice belong to the same part of the same family tree. We're both mammals, but humans and mice are actually fairly closely related. We belong to a group of scrappers and leftovers in the mammals called the Euarchontoglires, but I wouldn't ask a mouse to pronounce that. But we're much more closely related to each other than to dogs or cows or whales or bats. But mice and humans diverged a long time ago. I mean, our last common ancestor was probably living not long after the dinosaurs became extinct. So I think it's because of that closeness of relationship. But one thing that scientists have found is it's not the raw sequence of the DNA that makes you similar, it's how you use it. The DNA is cut up and sliced and diced and used in all kinds of different ways. So that has probably more to do with explaining the differences. So there's that one. Jennifer Murphy asks, I would be interested to know Mr. G's thoughts on whether our innovations and discoveries are happening at a faster pace because of our current technology as compared to earlier times in history. Oh, yes, assuredly so. The technology is expanding at a faster pace. I can't believe it that I joined Nature 34 years ago, and the pace about it is astonishing. I mean, they're marvelous new techniques that have allowed us to sequence DNA much more cheaply and much more easily than was ever possible. So the machinery is helping us. I mean, the latest innovation is artificial intelligence that allows people. Artificial intelligence isn't really very intelligent, but what it is very good is recognizing patterns very quickly and learning from them. I've just published a paper in Nature that shows that the evolution of some tiny plankton it relates to climate, the phases of climate change over millions of years. And that is we could only find that out because computers could scan and analyze hundreds and hundreds and hundreds of fossils, which and can do it all night without having to have a break. That it just wouldn't have been possible. AI is the next big thing. Jamie Shreve. Hello, Jamie. Jamie says, can I say about the origin and evolution of sight? Well, I think to have sight, you have to have light. One of the objections to Darwin's idea of evolution was how could you have an eye, something so complicated and beautiful as an eye, if it didn't originate all at once, because half an eye is not very good. But it certainly seems that many organisms are capable of detecting light, and so they can tell light from dark. All you need to do is to have a sensitive cell with a nerve attached. And the problem is screening the light out so that it doesn't affect everything. So you have these little pigmented spots, which are eye spots, and a lot of animals have those. And then what tends to happen is a spot at the bottom of a little cup-shaped in-pocketing tends to focus it more, and it does it better if it's got a little membrane over the top and you've got muscles to move the membrane in and out, and lo and behold, you have a camera eye. Now, lots and lots of things have eyes like us. Octopuses do, but also there are tiny single-celled creatures that have evolved tiny microscopic eyes with a lens and a cornea and a retina. It seems to happen quite a lot. So one thing I've found about evolution is if it evolves once, it's going to evolve a lot of times. You tend to get things evolving an awful lot. This comes to the beginning that life finds a way, as Ian Malcolm said in Jurassic Park. If there is light falling on an organism, it will find a way to use it. I think one of the first things that organisms used light for was photosynthesis. When algae found themselves at the surface of the sea in sunlight, of course, the problem living in sunlight is the ultraviolet light that is very damaging. So some of these algae created pigments, sunscreen, to absorb the light, probably from some waste product or another. But then they had all this energy of sunlight bouncing around, and so they put it to work, and to use that the energy from sunlight to drive chemical reactions. And so we have photosynthesis. So harm became harvest. And one thing I found is that creatures always find a way to turn disaster into opportunity. It's as if they've all been at management training courses and say there are no problems and difficulties, there are only challenges and opportunities. So thank you, Jamie. I hope I've helped explain that. Oh yes, he's gone away. I'm going to have more tea now. I wonder if there are any more. No, they're all an absolute silence. One thing that people have asked me is why there are no pictures in the book. I do have time charts in the book, but I wanted to make the book very small and easy to read, because as you know, going into bookstores and libraries, there are so many books on evolution and the prehistoric world that are full of pictures. But here's something about the pictures you see of dinosaurs. They're all complete fiction. I don't mean that the dinosaurs didn't exist. I mean that most of all the reconstructions we see are based on a small amount of fact with a great deal of supposition put in. So I do want, and I've done this myself. I wrote a book called A Field Guide to Dinosaurs with a fantastic artist called Louise Ray. And we said this book is a work of fiction. If we actually could have a time machine and travel back, these dinosaurs would probably look quite different. Oh, Chris has helpfully come back with a question. How did human consciousness evolve? Well, here's one. I'm going to be rather naughty here. I don't think consciousness actually exists. I think I'm not sure that it really exists. And the problem is with consciousness is that we're the one doing the thinking. And it's very difficult to stand outside human beings and ask if we're conscious. And here's an example. Here's an example of what I mean. It's all very human-centered. We can't help it. We can't help but be human-centered. We can't help be human-centered when trying to decide whether other animals are conscious. So the standard test to decide whether an animal is self-aware, which is a mark of consciousness, is to paint a spot on the animal somewhere where it can't see it and then get it to look at itself in the mirror. And if it looks at itself in the mirror and starts picking at the spot, you know that the animal can see itself in the reflection, which is great. Some apes and birds and dolphins are known to be able to do this. But what if the animal isn't very good at vision? What if the animal is very good at smelling? Now, I can see this, when I take my dogs for a walk, they stop at all these lampposts and gateposts and blades of grass and sniff and spend a great deal of time interested in things that I can't see and I'm not aware of. They see the world through smell. Dogs fail the mark recognition test. Of course they do, because their world is based on smell. Now, would a dog find humans to be conscious? Because dogs can smell each other's identity quite easily, but we can't. We're very, very poor at this. So to a dog, we might not be conscious. So I think consciousness is rather relative. I subscribe to Daniel Dennett's view, which he wrote in a very difficult book called Consciousness Explained, which some wag called Consciousness Explained Away. I summed it up in the last chapter of a book I wrote called The Accidental Species, where I do wonder whether consciousness actually is a real thing at all. Sorry about that. Kim Kendall asked, is it hard these days to obtain funding for the research you do, given all the competing research and worldwide problems? Well, I'm not a researcher. I'm a recovering paleontologist. What tends to happen is there are far too many PhD people created for all the academic jobs that could possibly exist. And a lot of people decide to become journalists instead, which is what I did. But yes, it is hard to obtain funding. There is a problem in research about the lack of career structure for scientists, but that's probably not a question that I want to go into much, because I don't know a great deal about it. But all my scientist friends tell me they're all very nomadic. They have to move from one temporary position to another all around the world, and it's very difficult if they want to have a family or a mortgage or anything like that. So that Susan Dexter asked about video games. Do you think all the video games played by the very young will affect their brain processing? I don't know. I think there are pros and cons about this. It's not something I discuss. There are some studies to say that some video game playing is actually quite useful for some things. Although my wife tells me that if I don't get off my iPhone, she'll throw it in the pond or the sea. Mr. or Mrs. Anonymous Attendee says, can I tell you about the 3 billion years that we have in the future? Of course. Human beings won't last for very long. We will leave the stage at some point. But although the Earth will exist for another 5 billion years or so, life will probably become extinct in about 1 billion years, because at the very largest, most panoramic scales, life on Earth, with all its comings and goings, is described by just two things. One is the general decrease of carbon dioxide in the atmosphere, and that's right, I said decrease. And the other is the increasing heat of the sun. Now, carbon dioxide has its ups and downs. At the moment, it's dangerously up and should be down. When it's really down, we tend to have ice ages, because carbon dioxide promotes the greenhouse effect, which keeps the Earth warm. So as if there's less carbon dioxide, the Earth cools, and we tend to have ice ages. But there is less and less carbon dioxide. Does this mean the Earth will freeze? No, because the sun is getting hotter. The sun is getting slowly hotter and hotter. And as life goes on, it will have to cope with a hotter, drier, and more difficult world in which it is difficult to extract energy, because carbon dioxide is the base of the food chain. It's plants that suck in carbon dioxide and mix it with water and sunlight to create the food on which everything else depends. And sometime in the far future, life just won't be able to do it anymore. It will just give up. It just simply won't be possible. So what I do in the book is I speculate on the kinds of creatures that might do this. Now, one thing I have noted in the book is that as life evolves, as life meets challenges, it tends to undergo a step change in complexity. Faced with a worldwide glaciation 2.5 billion years ago, life evolved from bacteria to become nucleated cells. And then slowly, in various ways, they became multicellular, lots of cells sticking together. So slowly there were little plants and little animals, but the animal life got started after another period of glaciation about 700 million years ago. That's when animal life started to get going. And what we see with Will Rivers asking me about trees, and I'll come to that because it bears on this. What we see slowly over evolution is organisms tend to form contracts or associations with other organisms. All plants on land have associations with fungi that help them extract minerals, and these fungi link up with other fungi underneath the ground, so that any woodland you walk into is basically one big superorganism. And you find that ants and bees and wasps, social insects, are among the most successful creatures on the earth because they have combined lots of individual animals into one big superorganism, and they bring along a lot of other animals and fungi and other insects, and they also have very close associations with certain plants. So I predict that in the far future, organisms that are individual freewheeling organisms will become rare, and most organisms will be part of vast collective organisms that were once plants and animals and fungi, but are all organisms all mixed together. That's what I tend to predict. Will asks about the origin and evolution of trees. Have they changed as the climate has changed? Would we have birds if there had never been trees? Well, I can answer the last one. Probably not. There are a lot of animals that live in trees that have evolved flight, because if an animal climbs up a tree and falls out, it's a very good adaptation to have something that makes the fall less catastrophic when you hit the ground, such as some kind of membrane to glide and ultimately fly. Although I think in birds it was a mixture of flying up from the ground and flapping out of trees. But when plants first made landfall 400-ish million years ago, they found an environment that was very different from the sea. In fact, for marine creatures coming to land, the land was as hostile as maybe landing on the moon. There was nothing to support your weight. It was very dry and desiccating and hot, and the temperature would change a lot, and it was hard to breathe. But one thing that plants found very quickly is they were competing with other plants for sunlight. And so it became a useful thing for plants to grow upwards as soon as possible and find ways to support their weight by lignified hard tissue. And trees have changed. Some of the earliest coal forests were nothing like forests today. The trees there were more like giant horsetails and giant weedy plants that didn't have trunks of heartwood. They had rinds, thick rinds at the bottom, and they use carbon very, very wastefully. In the sense that when you have a tree now, the tree grows up and pretty much stays there, and it reproduces each year using flowers and leaves and things on the same branches. But some of the trees in the coal forests, they shot up into the air, did all their reproducing, and then died, and then would have to shoot up again, a bit like ferns do, only the size of massive trees. So they sucked in huge amounts of carbon dioxide. they collapsed onto the forest floor and then basically lay there rotting not very well. And this was a period of about 70 million years when this happened. And all the coal, almost all the coal that has ever been mined was laid down in a very heady period of 70 million years in the Carboniferous period. The clues in the name. So trees originated pretty quickly. I think there would have to be, in any kind of evolution on land, there would which has creatures that use sunlight to feed. There would have to be trees because there's competition between trees for the sunlight, and of course the trees support a lot of other creatures in the forest and so on. David Rousman asks, In Search of Deep Time, one of my earlier books. On page 207, I say, Neanderthal DNA is not only very different from that of modern Europeans, but completely outside the known range of variation of Homo sapiens. Do I stand by that? Yes, I do. The sequence of Neanderthal DNA in general is completely outside that of modern humans. Now, that doesn't mean that most people don't have a smidgen of Neanderthal DNA. In fact, any human lineage, now that was 20 years ago and we didn't know about the introgression of DNA. I have a story about this. I went to a symposium on ancient DNA at the Royal Society in London, and at these symposia the fellows of the Royal Society are allowed to go in for free, and some of them are the old retired and somewhat eccentric scientists who have nothing better to do. So a scientist was talking about genetic introgression between humans and Neanderthals and other early hominins, and this fellow stood up and said in a cut class tone, "Are you telling me that these things copulated with each other?" He said and I was tempted to stand up and say in similar cut glass tones, not only did they copulate, but their union was blessed with issue. But then I realized just in time that proceedings at the Royal Society are all written down and documented, so I decided I would stay in my seat. All lineages in humans that are not exclusively African, all the way back to the year dot, have between 2 and 4% Neanderthal DNA. And lineages that are exclusively African have traces of early hominins which we know only from their DNA. They haven't been discovered as fossils. People in East and Southeast Asia have smidgens of DNA from another Neanderthal-like creature called the Denisovans, which were, I like to call Yetis, because they evolved on the high plateau of Tibet. And even though they came down to lowlands and a lot of their DNA is found in people across the Pacific Ocean, the gene that allows Tibetans to breathe happily at high altitudes where other people faint dead away gasping is a legacy from the Denisovans. In fact, Neanderthal DNA is in the spotlight because some of it is believed to make us more or perhaps less susceptible to COVID. I can't remember which is which. So in David's question, yes, I do. But of course, the great thing about science is that it changes all the time and it's always modified in the light of evidence. Now, I'm very pleased to say that my book, which is just out, is already slightly out of date. I mean, there are a couple of papers of things that have come out since I was writing and I wasn't able to put them in the book that I'd certainly put in the footnotes. Mary Tuke Klempt says, what is a major question that lingers in your mind and you don't know how to approach in research and studies? I'm beginning to think about human extinction. In the book, I mentioned that humans arrived, and then I leap gracefully over humans and then talk about what happens after humans are extinct. And I'm not very clear, deliberately, because I don't know, when humans will become extinct. Well, I've been thinking about this, and the more I think about it, the more depressed I get about the human life on Earth. And I wrote an example. I wrote a piece in Scientific American last week that has given everyone the screaming abdabs, because I say that human extinction might be quite soon. I don't say how soon. I think within less than 1,000 years, for all sorts of reasons. But that is a major question that I'm going to look at soon. And as Tom Lehrer said about songs of World War III, if we're going to write songs about World War III, we'd better start writing them now. Well, I say the same about human extinction, so I have to kind of get writing that book pretty quick. That's the thing I'm interested in now. Brian Slawski says, since you alluded to this in answering the question about science, are there examples of convergent evolution you find particularly striking or interesting? Oh gosh, it just happens all the time. Convergence is just rife. There's another one that I allude to in the book, which is all about South America. Millions of years ago was an island continent, and like Australia, it was colonized entirely by marsupials. There were marsupial saber-toothed tigers, there were marsupial bears, there were marsupial all sorts of things. And these are the things that just keep coming up. One of the things that doesn't seem to happen very often is creatures without tails walking upright. Human bipedalism is the most maladaptive, ridiculous thing I can think of, and is the reason for a great deal of back pain and absenteeism and falling over. But there was a lineage of ape that lived on an island in the Mediterranean that is now Tuscany, which experimented with walking bipedally like humans do. And there evidence of footprints on the island of Crete that show that there were bipedal apes living a long time ago. Didn't do them any good either. So anonymous attendee asks whether I could talk about interspecies communication. There seems to be a lot of attention on a fungal matrix of communication in forests and soil. Yes, I know the one you mean. I talked about this earlier, that most or all land plants on their roots host fungi called mycorrhizae. And the food they do this, it's a bit like hair extensions on the roots. They give the fungi food in exchange for the fungi mining minerals from deep within the earth that the roots can't get at. But one thing that fungi do is they link up with the other fungi attached to all the trees, and through that, trees communicate, of different species communicate with each other, in the sense that they shuttle or withhold nutrients from each other. And you've heard the expression wood wide web. Well, I have to say I invented that in the press release for a paper by a lady called Suzanne Simard, who's written a memoir. And there's a great deal of it in a marvelous book by Merlin Sheldrake called Entangled Life, which is all about fungi. I encourage you to read that. One thing I'm rather sad about interspecies communication is the fact that human beings are the only species that communicate by talking in the way we do, and that as recently as 50,000 years ago, there were at least 5 other ones with whom we might have had a conversation. And some of these creatures had, well, I'm thinking particularly of Neanderthals, had a deep internal religious life. And they would have had definitely a view about our place in the world. I've got all sorts of things here. Jennifer Murphy asks, I would also be interested if anyone is continuing the work that Albert Einstein was able to finish. That, I'm afraid, is way beyond my pay grade. That's theoretical physics, that is. Go and read the books by John Gribbin, and that would help you. Thanks, Megan, for Suzanne Simard. That would be extremely interesting to see. Angela Scarlis. Oh, no, hang about. I'll come to that, Angela, in a minute. Lee Zia, could non-carbon-based life develop, and what might be the evidence for such? Perhaps we can observe now. Well, that's very interesting. This is a question which is, it's life, Jim, but not as we know it. Now, a book I have yet to read is my friend Carl Zimmer's book, Life's Edge, which talks about the definition of life. Now, some people have speculated that life might not be based on carbon, but on some other element like silicon. It's possible, but there could be living things that obey the dictates of life that are completely different. They might be made of flux tubes of magnetic fields in the atmospheres of stars, for example, which would do things that life does, which is to halt the decrease of entropy, or at the expense of the surrounding. Well, entropy is a measure of disorder in the universe, and the universe is becoming slowly more disordered, and what living organisms do is halt or reverse that process at the expense of causing more disorder in the universe, in the immediate vicinity. One tends to think of teenagers' bedrooms, for an example. Their teenagers are growing and becoming more ordered in themselves, but cause a great deal of disorder in the environment. And as we get slower and older, we learn how to tidy up after ourselves. Angela asks, do you think life could leave our Earth and find another planet to survive? Yes, although planets are very far away. Now, human beings are the only organisms that we know of that have deliberately left the Earth and landed on another planet or moon, the moon. But only 12 people have done it. The last person who did it was in 1972, and they were all men. So establishing a viable colony on another world has yet to happen. But it is known that some bacterial life can at least survive the exposure to space. And it's possible that life can be blasted from one planetary surface to another early in the formation of the solar system, for example, between Mars and the Earth, but it's very unlikely. That doesn't mean it hasn't happened. Anonymous attendee says, is there any evidence for extraterrestrial intervention or intelligence? Any disruptions that can't be explained by evolution? Well, no, but it might be quite hard to understand. I've just finished a book by Michio Kaku called The Future of Humanity, and at the end he talks about time travel. I'm not sure that time travel, for example, could exist. Otherwise, there might be people coming back from the future who are telling us not to do things. I don't think there is actually any intelligent life on Earth, or so my son says, because he says that he's only here until the lizard people come and claim him for their own. And who am I to disagree? I would love there to be extraterrestrial intelligence. We haven't found any yet. I would think, though, that life actually is very common. I mean, very simple life, because there are lots and lots of planets. Water is very common, and life on Earth originated very, very, very quickly. So I think there's probably life on other planets, but whether it's much more than slime. Now, Susan asked another one, but I'll come to that in a minute, because Andy Clark asked a relevant question. Life began very early in the history of the Earth. Can I be a bit more specific about the timeline? Yes, I can. Of course, it's all very controversial. The earliest life that everyone agrees about lived 3.4 billion years ago. in Western Australia, and it wasn't just a little cell; it was an entire reef. It was a whole reef ecosystem, but made of bacteria, bacterial slime and sand and sediments all mixed together. Coral had yet to evolve. It wouldn't evolve for another 3 billion years. And this was a reef. You could probably have seen it from space. And that's the earliest evidence that everyone agrees about. But that suggests that there was life earlier. Now, there is evidence of life of the same general sort, that is microbial reefs. This is 3.7 billion years in the tropical paradise that is now Greenland, but not everyone agrees about it. But there is very tentative evidence of life 4.1 billion years ago. Extremely tentative, but that is only a few 100 million years after the planet formed, and when it was still being bombarded by asteroids big enough to cause impact craters on the moon. So life originated almost as soon as it possibly could, and possibly sooner than that. So this is one reason I say that life is probably very common in the universe, although it doesn't have to be very complicated. Susan asks, do I think human short-term focus is one of its biggest factors towards extinction? Yes, unfortunately. It's because we don't live very long, and we're not very good at looking at the big picture. One of the things I've since writing my book, I've tended not to do is look at the news or read the news very often, because it just frightens people. It concentrates on very short-term, ephemeral things. Now, of course, you know, I have the luxury of doing that. I'm a paleontologist, and I tend to think in millions of years. But there is a short-term focus. Now, here's something I raise in the book. There has been a great deal of hysteria about saving the planet. Now, a lot of it is very justified. But it's not the planet that we need to save. The planet is perfectly fine. It was in existence a long time before we came along, and will be in existence a long time after we've gone. What we need to do is save ourselves. Now, one would get the impression from hearing from environmental campaigners that a lot of the environmental threats that we face and have been caused by humans have been here forever. They haven't. They haven't been here for very long. The plastic bag that, now in America, you're all very good and take everything out of your supermarket in brown paper bags, but in Britain, we have had plastic bags, and supermarket used to give them out for free until quite recently. But if you were a young person, you think that we'd always had plastic bags. But I can remember being taken to the supermarket by my mum. I'd say, "Oh, Mum, I don't want to go to the supermarket." And she'd say, "Well, I didn't raise enormous sons like you, if not to get things off the top shelf in the supermarket." And plastic bags were new 50 years ago. And even then, people were worried about their environmental impact. A slightly longer impact, the internal combustion engine that causes a great deal of pollution and general fuss and bother. That was only invented in 1876, which is hardly any time at all. And within 30 years, it'll be antique. You will only see it in race cars and vintage car fairs, because everyone will drive electric cars if they drive anything at all. So it's a passing thing. We tend to think about the great threat of air travel. Well, the human technology has increased, and so it will decrease. Nobody's been to the moon for, what, 50 years? And yet it was 50 years between the first moon landing and the first transatlantic crossing in an airplane. In 1919 was the first transatlantic crossing by two fellows in a contraption that was made out of lawnmower engines, canvas, balsa wood and string, and they crossed the Atlantic. And more or less 50 years to the day after that, people landed on the moon. So the human environmental threat and the human population increase is very, very recent, within the past 200-300 years. So people keep talking we're living in the sixth mass extinction and becoming quite hysterical about it. Well, we're not. We're not living in the sixth mass extinction. The background rate of extinction is certainly up. And because human beings sequester up to 40% of all the productivity of the Earth's plants, and that's a zero-sum game, that inevitably means that there's much less for other species, which are therefore becoming extinct. However, we'd have to keep doing this exactly as we are without stopping for 500 years before it qualified as the sixth mass extinction. And we are already stopping. We are already making changes. People don't seem to realize that the world population, which was expanding at 2% a year in 1968, is expanding at just 1% a year. It's going to top out by the 2060s and start declining. So the yes, Susan, we do think in very short-term ways. We don't think in the long term. There are very good things that are happening in the world that will make our decline more comfortable. The main one is that just in the past 100 years, the most important single factor in the betterment of humanity is the social, political and reproductive empowerment of women. Just in the past 100 years, it has doubled the workforce, resulted in more people being educated, living longer and genuinely in a more affluent and healthy condition. This is the single most important factor in the world. However, human beings will become extinct because all creatures become extinct. When you tend to think of people living for millions of years, you only hear of physicists or science fiction writers talking about this sort of thing. It ain't going to happen because we're species. We're not going to live forever. We're not made to do so. As you see, I'm losing some of my teeth. I'm over 40. You know, when you're over 40, your teeth fall out. And people aren't really meant to live any longer than that. After that, it's kind of borrowed time. Except my parents who are in their mid-80s who have got wonderful teeth, but then they can pay for orthodontics, which I've decided not to do. My dentists say, why don't you have a replacement? I say, well, look, luckily I don't depend on my good looks to make a living, so I'm not going to bother. There we are. That's the way we're made. Short-term focus, yes, I think that is a big problem. I hanker for the days when we all sat round the radiogram at 9 o'clock in the evening for the BBC News, and that was your entire news, and it wasn't 24-hour news, and you weren't frightening yourself every minute of the day clicking on the news. I think it makes people terribly anxious. Don't do it, people. Stop it. So I think we're coming to the end of our time now, yes, unless anybody wants to ask anything more.
Well, Henry, this has been absolutely fascinating and such a fun to hear you answer these questions. I really appreciate you taking the time to talk with us all the way in
You're very
Virginia.
Welcome. You're very welcome.
Henry's book
there it is.
Very short history.
I've got one here. Yeah, there are 2 copies. You see, yeah.
They exist. This book is published by St. Martin's Press and can be borrowed from the library and purchased currently wherever books are sold. And I do recommend reading it. It was very fun, and it's something you can read over and over again and learn something new every time. So this has been wonderful, and I thank everyone for joining this call tonight.